Okay, so what if you could direct a voice actor, change the emotion in a recording, or even just fix a silly mistake? Not with some super complicated software, but just by typing. Well, today, we're diving into this groundbreaking new AI that does exactly that. It lets you edit audio just by using simple, everyday words. It's pretty wild.
Just think about this for a second. I mean, really think about it. Instead of getting lost in timelines and waveforms, you could just type. Something like, hey, make my voice sound a little more energetic right here. Or, you know what? Get rid of that awkward pause. That's the huge promise we're talking about today. And believe me, it is way closer than you might think.
So you might be asking yourself, why didn't we have this already? It sounds so simple, right? Well, for years, speech AI has been stuck on this fundamental problem, this really deep technical challenge that basically forced developers to pick a side.
Okay, so here was the big problem. You had two different goals. An AI built to understand speech. It only cares about the meaning, right? The semantics, what's actually being said. But then you have an AI built to generate speech. That one has to focus on the sound, the acoustics, the tone, the pitch, all that emotion. And for the longest time, these two things were like oil and water. Any model that was amazing at one was, well, pretty much terrible at the other. So to solve this, they needed a completely new approach, a whole new foundation. They had to find a way to bridge that gap, to somehow combine both the meaning and the sound into one single elegant package. And that solution, the key to all of this, is something called a unified token.
Right, so unified token? What on earth is a tokenizer? Let's break it down. Think about it like this. For an AI to read a sentence, it first has to chop it up into individual words, or what we call tokens. A speech tokenizer does the exact same thing, but for audio. It takes this super complex sound wave and breaks it down into these small, manageable little chunks that an AI can actually understand and work with. And that brings us to the hero of our story today, Ming UniAudio. This thing is the breakthrough. It's the very first tokenizer that actually successfully manages to integrate both the meaning and all those acoustic details of speech into one single unified token. It doesn't have to choose sides anymore. It gets the best of both worlds. And the way it works is just brilliantly simple. You can see it right here. It takes in the raw audio, and then, this is the magic part, it weaves together both the semantic features and the acoustic features into a single representation. What comes out are these incredibly powerful unified tokens that, like I said, contain the best of both worlds. Okay, so now that they had this revolutionary tokenizer as the foundation, what did they do with it? Well, the researchers built a brand new, super powerful large language model for speech on top of it. They calls it Ming UniAudio. And its performance? Honestly, it's just staggering. But how good is it really? Well, get this. On a major industry benchmark, it didn't just do well. It set new state-of-the-art records in 8 out of 12 different categories. So this isn't some cool idea on a whiteboard. It's a legit top-tier performer that is blowing past previous models in both understanding and generating speech. And look at this number, 0.95. What does that mean? Well, in the super challenging task of Chinese voice cloning, it got this score. You don't need to worry about the acronyms, just know this. A perfect score is 1.0. So 0.95, that is incredibly close to flawless. It means its ability to generate realistic cloned speech is just, wow. Okay, this is where it all comes together and gets really exciting for you and me. The team took this powerful base model and trained a specialist on top of it, and they called it Ming UniAudio Edit. This is the model that lets you become an audio director with, you guessed it, nothing but your keyboard. I mean, look at this. This is a real example of an instruction it can follow. It's just conversational. It's descriptive language. We're not talking about code here or complex commands. You literally just describe the change you want to hear, exactly like you'd talk to a human voice actor. And this part? This is a game changer. For anyone who's ever edited audio, you know the pain, right? The agony of trying to find the exact millisecond to make a cut or a change. Well, this model gets rid of that completely. It understands the context of what you're saying and your instruction, so you don't even have to tell it when the change should happen. It just knows. So this really breaks down the two powerful kinds of edits you can make. On one hand, you have semantic modifications. That's where you're literally changing the words themselves.
And on the other hand, you have acoustic modifications, where you're changing how the words are said, the tone, the emotion, the pacing, all of it. It's basically a universal toolkit for speech, and it's all guided just by plain English. But look, this isn't just about a cool new toy for creators and podcasters. The impact of this research is actually way bigger than that. It's pushing the entire field of AI forward in a really significant way. See, this team didn't just build a model and call it a day. They built an entire ecosystem for the future of audio AI. They created the very first benchmark for this kind of free-form audio editing, which sets a whole new standard for everyone else. And maybe most importantly, they open-sourced everything: the models, the tokenizer, all the tools. They're not just showing off their work, they're literally inviting the entire world to come and build on top of it. They've essentially unlocked the door to universal audio manipulation for all of us. So what does this all mean? It means the line between writing a sentence and crafting a piece of audio is just dissolving. The power to direct, to refine, to totally perfect speech is becoming accessible to pretty much everyone. And that leaves us with just one big question. When you can edit sound as easily as you edit text, what's the very first thing you would create?